So Segon, Sewa. Hello, everyone, and welcome to our final episode of the STOODIS Science Indigenous Scientist Chats. If you were here with us last week, welcome back. But if this is your first time joining us, my name is Jenna Barnhart, and I am the Indigenous Research Assistant for STOODIS Science. If you've never heard of us, we're launched out of Ryerson University's Sci Exchange program, and our objective is to promote science research, science knowledge mobilization, and knowledge translation, combined with traditional Indigenous teachings to Indigenous students. If you're interested in hearing more about us and what we do, you can find us here at all social media platforms at Sci Exchange RU, or more information can be found on the website here on the screen. Just real quickly, we'd like to give a shout out to our friends at Let's Talk Science, who have been able to share this presentation platform for us. So thank you so much for allowing us to use this digital platform to showcase our speakers during this series. And on today's program, we welcome our final speaker, Dr. Hilding Nielsen. Dr. Nielsen is a Mi'kmaq and a member of the Kalapu First Nation in Newfoundland. He is a CLTA assistant professor in astronomy at the University of Toronto, where he studies stellar physics and exoplanets while working to integrate Indigenous knowledges and methodologies into the academic study of astrophysics. So welcome, Dr. Nielsen.
Thank you very much for having me. It's a great pleasure to be here. Let me see if I can share my presentation without blowing up my computer. Hi, everyone. It's a great pleasure for me to be here. As said, I'm Hilding Nielsen, work at the University of Toronto. It's a great pleasure to be sitting in the land of Toronto, the land of the Mississauga, the Haudenosaunee, the Wendat peoples. And I am honored to be a guest, and I hope I work to honor this land. I want to talk today about one of the most exciting parts of astrophysics today, and that is exoplanets. I'm looking for planets going around other stars, trying to understand whether they might have life on those planets, what kind of life, what do these planets look like? And today we're in this really exciting time because we know of thousands of planets in our galaxy orbiting other stars. Our solar system, we have 8 planets, 9 if we count Pluto, and I'll count Pluto because I think it's cool. But we look around our galaxy, we see thousands more planets, and they're very different than what we see in our own solar system. Just looking at our galaxy, we've only just given the surface of finding exoplanets in our galaxy. You see this map of our Milky Way. It's an artist map interpolated from observations because we can't send a satellite far outside of our galaxy to look down. Most known exoplanets are very close to our solar system. Some are in this little triangle in one direction, which is from a telescope called the Kepler Space Telescope, which just stared at one small postage stamp in the sky for years. And then there are a handful of planets discovered using other methodologies. But when we look at the scale of our galaxy, we've only just started skimming the edge. But we still found thousands of exoplanets. This is so cool. So we've found 4,000 right now, as of January, 4,000 confirmed exoplanets. And humanity only observed a tiny fraction of our galaxy. So if we were extrapolated, we're talking about billions of exoplanets, all of which have the potential to have their life of their own, whether it's cellular life or human type life or advanced life, we don't know. But there's so many possibilities that we're just beginning. And we found these planets by very difficult techniques. And we could think about how we do this by thinking about the cute little firefly. And you can see a firefly emits its own light, just shines on its own. And when against this dark background, we can see it so clearly. But if you put in front of the headlights of a car, where is that firefly? And that's what the astronomers tried to do. we're trying to look at a star which is millions of times brighter than any planet, and we're trying to find the planet next to it, right next to it. And it's so hard. But we are able to do this today thanks to one of the most popular methods. There are multiple methods for finding exoplanets, but one of the most popular methods is called the transit method. And in this method, we stare at the star using a telescope, and we hope that the planet moves right in front of the star. And when it moves in front of the star, it blocks a little bit of light from that star. And so if we were to map how much light we see as a function of time, when the planet goes in front, that light dips. And because the planet is going around in an orbit over and over again, we should see that dip regularly and be able to confirm that it's an exoplanet. So we see that's how Kepler Space Telescope discovered most of its exoplanets, how we're discovering exoplanets using the Transiting Survey Telescope, and how we'll discover more in the future. And we could take this a step further. We can actually start characterizing how exoplanets look. And most of them look nothing like what we're aware of in our solar system. Many of them are called super Earths or sub-Neptunes. So, these are planets that are radius and mass that are greater than the Earth. So they're denser and bigger, but they're still rocky objects like the Earth and Mars and Venus, but they're bigger. We didn't really expect that. On the other hand, many exoplanets look like something called a hot Jupiter. A hot Jupiter is, think of if we take Jupiter, which is 5 times further away from the sun than the Earth, and we just take Jupiter and we put it in Mercury's spot. And so that Jupiter, this giant giant planet, is getting all the radiation from the sun and heating up, puffing up. So we call it a hot Jupiter. But the problem is that actually most of these hot Jupiters aren't at where we would think Mercury is in our solar system, but even closer. And we have no idea how they got there. We don't think that a planet could form a dense, thick atmosphere of gas like Jupiter or Uranus or Saturn if it's that close to the sun, because the radiation would heat up all the gas so much that it would just eject all the gaseous material. So we have all these questions, and we see the exoplanets in our galaxy look completely different from what we expect. And if we look at all these orbits, here's just a sample of the orbits. You can see towards the right is the mapping of the orbits of planets in our solar system. And superimposed are all of these orbits of different exoplanets. And the size of the exoplanets are marked as bigger circles or smaller circles. And they're so much closer than, say, Mercury is to the sun. And we see these everywhere in our solar system. Of course, we have a bias towards these. Because we use the transit method, where the planet passes in front of the host sun, a bigger planet casts a bigger shadow, which makes it a little easier to see. So we see these bigger planets more often. But we've never yet found a clear, confirmed Earth analog or an Earth 2.0. We're still looking. There's some candidates, but we haven't found anything that looks like where we're from, like our home. Now, mostly because, as you saw in the orbits, they're very close to the host star. And we want to find something like the Earth because the Earth is in a special place in our solar system. We're far enough away from the sun that the light from the sun can heat up water and keep it from being completely frozen. But we're also close enough that, we're far enough away from the sun that, the light from the sun doesn't heat up the water and make it all gas so that it evaporates. Like water on Mercury would evaporate, or water on Venus evaporates. But we're close enough that the water isn't frozen either. So we live in a part of our solar system where we can have water, which is completely important to our ability to live in all of a water, gas, and liquid phase. And because of that, we can live in our solar system. So there's this interior line where water evaporates, and this exterior line, which is denoted by a snowflake, that if you're further away, all your water should freeze. And we're in this Goldilocks type zone for the sun, which is in the middle panel. And so we want to ask this really important question. we see all these planets, we see all these different issues. How many of them could have life? That's kind of a big question. This is something that people think about all the time. As from a different indigenous perspectives, we have all different answers to this. From if, say, you're a Cree or you come from the stars, life should exist no matter what. So we have all these different possibilities, and how can we understand this? So a scientist a number of years ago kind of decided to break this idea down into parts. And this is, while this is written as a mathematical equation, it's really just think of it as one of those Russian nesting dolls of ideas. And so Frank Drake, not like the really cool Drake, but Frank Drake, he explored the question of how many civilizations there might be in our galaxy. And I'll come back to this, all these different ideas, but I'll give you the brief description of this equation and how it breaks into nesting. And to understand this question, we need to think about how many stars are in our galaxy and how many stars are being born at any time, how planets form, etc. So we can think of it this way. If we think of the number of civilizations that communication might be possible, can be given by, well, how often do stars form? We need to know how many stars in our galaxy are capable of having a planet. So we need to know how many stars there are at any time. And not all stars live forever. Many, the universe is 14 billion years old, almost. Our galaxy is about 10 billion years. Our sun is about 4.5 billion years, but some stars will live millions of years. Some stars will live tens of millions of years. So we need to have an understanding of how many stars form every year in our galaxy. Then we want to ask, of all the stars that we have in our galaxy, what fraction of those have planets? Thanks to all those planets we discovered, we could sort of guess that's about 50%. Then we look to the next shell, and of those stars that have planets, how many of those planets can potentially support life? So if you have a star with a planet, what are the odds that the planet has the ability to support life? And this is a big question. Just looking around our solar system, do we think Jupiter can support life? Maybe Mars? A year ago, there was a report that maybe Venus had the potential of supporting life because they found some weird feature in the light. So we need to understand that as a big question just alone. Just even how many could potentially support life is a big challenge. Then we want to go in and ask what fraction of those planets that can potentially support life that actually do go on to support life. Of the planets that support life, that do support life, how many of those planets go on to evolve or create or have intelligent life? And of the planets with intelligent life, how many of those go on to have civilizations that develop technology that is detectable from space or from radio telescopes or so on? And then the final value, the innermost shell or outermost shell, depending how you wish to view this, ask how long do those civilizations that have technology that's detectable use that technology or exist? And if we bring all these things together, we can make predictions, very speculative predictions. We don't really know about how many civilizations there are in our galaxy. So and right now, the only thing we know is that based on our own experience, we would call humanity one civilization. And that's the only one we know of. We might guess there's a handful or a dozen, but probably depending on how we view these variables, not many. But it brings up this very important question. How do we define these terms on the right? I mean, we could probably have a very easy time understanding what it means to say the fraction of stars that can host planets. But what does it mean when we say planets can support life or can support intelligent life? What does it mean to be detectable from space? All these things are very difficult to understand, and they're very culturally based on various situations. So how do we find these ideas of life, intelligent life, civilization, which are can be very problematic. Even today, as we live in lockdown, we learned a lot about viruses in the last year, but scientists can't even agree if they're alive because they don't replicate on their own. They need a host to replicate. So how we define life is very difficult. But based on the idea of what I would refer to as traditional Western thought, how we live in Canada or the US or the UK, we think of intelligent life and civilization as us in this situation today. We think of our intelligence and civilization as being related to technology, construction, rockets, social media, all these different things. But why does that seems pretty limited. Why is that the apex of civilization? What if we revisit indigenous knowledges? I come from Mi'kma'ki or Datamagok, Newfoundland. And they're, how we view these things in terms of life and intelligent life and civilization changed dramatically when we look into our own teachings. And that change, and that's, just as relevant of a question of how we can learn from those knowledges as we learn from what we can refer to as traditional Western methodologies. We tend to view intelligent life in the West from the sense of a tree of life. And this is a very busy tree of every species that we know of on Earth, broken into different parts. Various, on the right, you see bacteria. Humans are somewhere around the top of this with mammals and apes and then fish. But there's so much life, it's very diverse. And we're only one branch on this tree of millions and billions of branches. Why are we the intelligent life? Animals are capable of caring. We know they're capable of mourning. We know of animals that build their own tools. We know of animals that have their own ways of communicating. I would say looking at cats are probably more intelligent because we feed them, take care of them, and clean up after them while they laze around and do nothing. Personally, that seems to me to be a very intelligent thing to do. So, there's so many different ways of thinking about intelligent life. But when Frank Drake was coming to the equation, the only intelligent life was humans. And so that creates a very narrow point of view. Of course, we can ask this other question, is how long do civilizations last, emit detectable signals? When Frank Drake came up with his equation, he was living in the height of the Cold War, when people were worried about nuclear weapons, nuclear bombs, and annihilation. It was Russia and the US. And so he sort of thought that, maybe we would only live, or civilizations would only live a century or so. But, it wasn't that long ago Canada celebrated its 150th anniversary as a country. And I remember this meme that's on the right here that was posted. Somebody did a billboard in, I guess in Nova Scotia, where, it was celebrating Canada 150, but Mi'kma'ki 13,000. Indigenous people have been on this land since time immemorial, tens of thousands of years. If we think of indigenous peoples as civilizations of their own accord, those lifetimes can be thousands of years longer than what Frank Drake suggested. So we could change these variables very much just by looking at how we view ideas in terms of how long civilizations last. So we could think about how might different indigenous nations, different cultures, different elders think about these ideas. And given Frank Drake was only looking at humanity through his own lens, there was nothing any more or less scientific than asking this question. This is part of our science because we are being more open and we are considering where we're coming from in asking these questions. And so to really pursue this, we need to sort of think about what does it mean to be to do science in the Western tradition versus what it means to do science in many indigenous traditions. And I say this completely noting there are no pan-indigenous knowledge systems. How Mi'kmaq people view the world, the universe, nature could be very different than Anishinaabe, Stolo, Inuit, so on, from around the world. But there are many commonalities that Indigenous scholars and leaders and thinkers come up with and really share. And so, part of indigeneity is what is above is reflected below. How we view the sky is a reflection of the land below. Which is very important, because that means our knowledge is contextual and localized. How we view knowledge is very much based on where we're looking, from where we're exploring. In the same vein, same idea, knowledge is also relational. When I look at something or I study something, I'm studying it from my own view, perspective, how I connect to it. Whether that is connecting through kinship or connecting through familiarity or relationality or location, that knowledge is relational and is an action, not an objective. Many Indigenous knowledges are, and this is one of the coolest things that I find, is many Indigenous knowledges think of multiple variables and ideas working concurrently together in this greater scope. And this reminds me of this idea and story with related to the caribou herds. So if you go to North Quebec, Northern Labrador, Newfoundland, Northwest Territories, the caribou herds migrate across the land every year. And almost every year, the migration path is a little bit different. And for a long time, and probably still, Western science has not been able to make predictions of how those herds will migrate or how to manipulate it in a very subtle ways. But elders know. The people who live on the land and they hunt, they know all the variables that go into this, and they intuitively understand how to manipulate and work with the herd migration. And that is so valuable for living and understanding on the land. But it's very different from what we would say traditional Western knowledge is. In many Indigenous peoples, knowledge is holistic. I don't mean holistic in any spiritual sense, though that is part of it, but holistic in that it's not siloed. Like, I work in a university in a department of astronomy. It's next door to a department of physics and down the street from a department of chemistry. And we might not talk to each other. We might not share our knowledge and then try to interact or see how our different fields sort of benefit each other in great detail. But an Indigenous story, Indigenous knowledge, gets used for everything. We talk about in constellations. In Mi'kmaq, we have the story of Muon, which for many people in the West would be the Big Dipper. And we could talk about that story as being astronomy. We could talk about the story as being how we relate to the bear, Muon the bear, how we hunt, how we live in nature, how we work with each other, and so on. So the knowledge has so many different paths and different threads to understand. Nature is sacred and holy or religious, however you want to do it, but it's also familial. We are related to nature, so therefore we're equal to it. That's a very important point, and how we view nature and how we work in science. On the other hand, on the right, where I list a couple of ideas from Western system, in the West, knowledge is objective. I observe something, you observe something, we should have the exact same result. I do an experiment, you do an experiment, we should be able to reproduce the exact same results. That knowledge should exist without our being a part of it. That's the objectivity of knowledge, which is very different from many Indigenous peoples. Western science attempts to reduce concepts and issues to the smallest number of variables and just try to vary one or the other and do different tests. Knowledge is siloed disciplines like astrophysics, chemistry, mathematics. And there's a hierarchy in nature. Humans are at the top of the food chain or hierarchy in nature. So therefore everything sort of ends up serving us, which is very much an issue related to climate, how we deal with climate change, how we view national parks, the lives of animals in urban settings, and so on. And so, but these things are very different from many Indigenous knowledges. Neither is more important or less important. They are equal and they can exist on their own, but they can work together. And we can, but we don't really, in astronomy, we've done very little to integrate or investigate how we can learn from Indigenous knowledges, or how we can see Indigenous knowledges in our studies. And so it's very valuable to see these ideas and think about how we can talk about them in terms of exoplanets, life in the universe, and think about these ideas. So if we use these ideas, we can think about how they impact the ideas like the Drake equation. And so we could talk about ideas like, what is intelligent life? If we have kin relations between different species of animals, whether it's the salmon, the bear, the moose, the elk, so on, the wolf, whatever it is, then they too have intelligence. And they have, so from indigenous perspectives, the number of planets with intelligent life would go way up, increase a lot. If we look at the number, how we view living in nature and the ability to communicate and technology, the lifetime of civilizations goes way up. You know, the Mi'kmaq people were a civilization, Anishinaabe people, civilization, still are civilizations that will go on in the future. So, you know, those lifetimes change dramatically and for time immemorial relative to the so-called 100 years that, you know, Frank Drake sort of estimated based off technology. And so if we just compare those two different ideas, like where indigenous peoples, the numbers go up greatly, that means the number of civilizations in our galaxy must also go up significantly, just from a couple indigenous-based thoughts, without actually doing any real change in what the properties of the galaxy are, but just looking at our own biases and our own cultural backgrounds, we have a very different view. Frank Drake saw a universe and a galaxy that had very few civilizations in it. But if we think from indigenous perspectives, the galaxy must be teeming with life. And if there's so much life out there, we should ask another question: where are they? At the same time Frank Drake was coming up with the Drake equation, another question was being asked. We live on the Earth, which orbits our sun, both of which are about 4.5 billion years old. And we understand that number by how we understand physics of the sun, by doing archaeological dating of meteorites. And so we see that 4.5 billion years. If we look at cosmology and the Big Bang and especially the universe and dark energy, we know that the universe is about 13.6 billion years old. So the universe was around for almost 10 billion years before we came around. And our galaxy formed about 10 billion years ago. So there's about a 5 billion year window where our galaxy lived and we didn't, as we understand in the West. But if our galaxy was existing, there were stars. Those stars could have planets. Those planets could have life. And they could have a 5 billion year head start on life in our solar system. And when Enrico Fermi asked this question, he kind of brought this idea is that if they had a 5 billion year head start, they could build ships and traveled our galaxy, ran into each other, built like a Star Trek kind of civilization in space, you know, Federation of Planets, so empires, whatever. And so if that's the case, why haven't they visited us? Where are they? And we could, you know, there's lots of questions about this from two different perspectives. But we don't really have, you know, unidentified flying objects landing in at the White House or at Parliament or anywhere that anybody's admitted to, at least. I don't know. But where are they? Where are all those civilizations? And this is a field of very popular discussion because people love putting solutions to what gets called the Fermi Paradox. One being that, well, civilizations that are too technologically advanced, you know, kind of annihilate themselves, which is a very depressing thought. But there's so many others. And so where are they? But we're also in this other phase. Not only do they not have to visit us, but do we have the ability to detect them? around their own stars. As I mentioned, we know 4,000 exoplanets. What if one of them hosted an advanced civilization? Could we see them? Could we find something that suggests that they exist? Maybe we can look for something called the Dyson Sphere. A Dyson Sphere came up in science fiction about 50 years ago, where it looked at what's the most efficient way to live around a star. And so we're on the Earth, we're so far away from our sun, and we intersect a little bit of light from that sun that keeps us, and that amount of light from the sun can generate electricity for people around the world, generates heat, photosynthesis, everything that helps us live. But that leaves a volume, a surface area of space, like if you go around the north, around the Earth, all around, that you can build a shell around the sun, but every point on that shell would receive the same radiation that we got on Earth. And so we can build this giant shell around our sun to basically intercept all the radiation, and we can live on this great big giant shell that's much bigger than the Earth. And so if there were advanced civilizations out there, perhaps they would want to be more efficient, and they would build a Dyson Sphere. So maybe what if we could detect it? Now, we probably couldn't detect a truly complete one because it would block the star. But what if we found one that was in construction? What if we were seeing like a big block, like you see in this artist impression, passing from the star, like we see with transit exoplanets? And we saw something like that a number of years ago. Now, in the end, it became clear that these were continents going around the host star and not a Dyson Sphere. But it created a lot of buzz and excitement. Maybe there are other techno signatures. Not that long ago, an asteroid was detected that came from another solar system passing through our own. It was called Oumuamua, a Hawaiian word for the traveler or scout. And some scientists have speculated that maybe this is a converted rocket ship or ship traveling through interstellar space. So maybe they're carrying passengers. It's unlikely, very unlikely. And there are a lot of different answers that can leave it as a natural phenomenon. But maybe that is a different idea. Can we find these things? But these are also very specific kind of signatures. We would refer to these as techno signatures. What we're looking for are signs of technology around another star. What about signatures of a planet that has biology, has biological processes, like plants creating oxygen, or humans creating carbon dioxide, or animals creating carbon dioxide? We have a planet that has an ozone layer and oxygen that was created by living creatures. The first oxygenization event on the Earth was created billions of years ago by bacteria that were photosynthetic. And so the fact we have so much oxygen in our atmosphere, the process of life existing, not just enabling life, but that it exists. So if we were to take our new telescope in space, the shiny telescope on the right is called the James Webb Space Telescope, or JWST, that's just been launched or being launched. And if we were to look for an Earth around another star, we might, when the planet passes from the star, we might try to observe the transit and break the light down into different parts in the wavelength. So we're from blue light, Roy G. Biv type rainbow light, break it into small parts. If we break it into parts and there's atoms in the atmosphere of that planet, those atoms might absorb light at very specific wavelengths and create a chemical signature of the planet. And so we could potentially detect the presence of things like methane, ozone, nitrogen, water in the atmospheres of exoplanets around other stars. And we're getting close to that point. And so if the Earth were to pass around the sun, an observer on a planet far away around another star might see us. And so likewise, we might see them. So we can look for biosignatures, whether in that case it's something like the Earth or something like a Martian-like planet. And maybe we can see all these different things existing and living. You know, and if we found a planet that had a lot of oxygen in its atmosphere, that's a good sign that there's life on that planet. So on the one hand, that's biosignatures, and these biosignatures can be created by single cell bacteria or intelligent life. And we're within a generation of doing this. If we're in a generation doing this based on the Fermi Paradox, where there are civilizations and cultures that have lived for billions of years, they almost certainly could have detected biosignatures on Earth, as well as detecting non-biosignatures, such as air pollution, the impacts of climate change, light pollution, smog, all these different things. They might even be able to detect that. I mean, it's a little creepy that somebody that are tens of light years away or hundreds of light years away might detect these things on Earth, but it's possible. It's entirely possible that they did. And this leads to a possible solution to the Fermi Paradox that's very different. Is that maybe aliens avoid us because the dominant society is so destructive and out of whack with nature. The difference between technosignatures and biosignatures is technosignatures are deviations from biology. When we see a technosignature, we're seeing something that is deviating from a natural harmony. If we're seeing uranium atoms in the atmosphere, or signatures of uranium, we're seeing things that are likely coming from nuclear power, so technology. Or if we're seeing things like carbon dioxide going out of, or methane going out of whack, we're seeing destructive properties. We're not really seeing biosignatures. And maybe aliens see that. And that's kind of crazy, that maybe they don't want to talk to the dominant society because the dominant society is destructive. And I kind of want to ask the question, and it's kind of a funny way of thinking about it. But what if a solution to the paradox, Fermi paradox, is not that, you know, civilizations sort of destroy themselves or get overly technological advanced, or that they avoid us because we are not technologically advanced enough to talk to them? Maybe it's that the galaxy is more like indigenous peoples. They're more in harmony. They live better. You know, they're not destroying their home planets as easily. Maybe they have different ideas of decolonization. Maybe instead of looking at life in our galaxy as being something akin to the Western tradition and techno culture or techno societies, maybe we should be looking at more, what would indigenous peoples do in tens of thousands of years from now, or hundreds of thousands of years from now? And maybe it's just a different decolonized perspective. And therefore they avoid us because humans don't do well with that. In that case, the biosignatures tell us one thing, that their life exists. It might not tell us about what kind of life, whether it's one cell bacteria or something like humans or something way more evolved, advanced, who knows? And technosignatures are the deviations from biology. What would advanced indigenous decolonized signatures look like? How, you know, from my own perspective, what would a Mi'kmaq futurism, or the future of Mi'kmaq people living in the land, living in culture, living in perspective and harmony, what would that look like to a civilization from tens of light years away? What if it's Anishinaabe or Haudenosaunee? What if it's Maori or Hawaiian or Mapuche in Chile? What does that mean then? Would we see them? Would we tell the difference? At least from a Western sense? Would it tell us something very different? I don't know. But I think But I think it's a valuable question to ask because we seem to be stuck in this bimodal sense of biosignatures, there's life, and technosignatures, there's something that's much more advanced than that in terms of ancient aliens or extraterrestrial or the movie Arrival or Interstellar type of thing. So that's the summary of my talk. And I hope that I brought the perspective that maybe being Indigenous is really good, something that astronomy needs and physics needs. Because Indigenous peoples have different perspectives that we don't see in the status quo in physics and astronomy. And this is very important for things like exoplanets and life in the universe. It's important for cosmology and the Big Bang. It's important for quantum mechanics, and it's important for relativity. And I think that Indigenous methodologies offers a great deal to change how we view the universe and astronomy. So, Welalia, thank you. I'd be happy to answer questions and take many questions. I'm gonna, I think there's some in the Q&A, so since I can't, so I'll bring up that and have a look.
Yeah, thanks so much, Hilding. That was really, really interesting. Yeah, there are some questions here. I'm just trying to figure out how to let you see them.
Yeah, I have them. I have 3 here brought up.
Okay, so yeah, the first one is, what's the most unique exoplanet you've ever found?
Well, unfortunately, I work a lot in teams. Astronomy is big as team, and finding exoplanets is very much about giant team building. So when we have projects like Kepler, there were teams of hundreds of people working on that. So the idea of finding one yourself is very hard these days. But I think some of the most exciting exoplanets I've seen, in some respects, are these really hot Jupiters. Like they're so close to their host star that the star is essentially using tides, like tides on the moon, to tear the atmosphere apart and to create this kind of belt of material. We've seen super Earths, and there's some. Sorry, I don't know if you can see my face on the screen here, but if I tilt up my laptop, you'll see 4 really cool planets here that you might see. Like there's one here that is a super Earth. And if you think about it, if you go visit this planet, because it's a super Earth, it has a lot more gravity. If you were to go skydiving, granted, I'm kind of a chicken, so skydiving seems pretty wild to me, but to do it on this planet, you can do it for days. Or if you're on Kepler 186F, this star orbits what's called a red dwarf star. So, and the red dwarf star is 3,000 degrees, whereas our sun is almost 6,000. And so most of the radiation on that star is closer to the infrared. And because the radiation is close to infrared, if that planet has things like grass and trees, its photosynthesis would be very different. It would actually be red from the photosynthesis instead of green. So there's all these different possibilities, and it's so hard to just think of one. Just so many amazing planets that helps us, I think, realize when we look at the Earth, it's very special in one way, but there's just life is just so amazing that the Earth isn't special. You can have life in so many different ways.
So like, just from my own perspective, so you think that the Earth is particularly unique in that sense, or do you think it's more common than we think? We just haven't found it yet?
I think when we talk about life in the galaxy, we tend to look at the Earth as the condition. And there's so many weird things on Earth with the conditions that seem to make life unique. For instance, our moon seems to be very important for life thanks to the tides on the ocean. But life seems to be also incredibly robust. Like, given the opportunity, all evidence suggests that life will form no matter what you do, and more or less. So there could be a great diversity of life in different ways, whether it's red grass versus green grass, or how so life's going to react and adjust in different ways depending on the situation. But I think the Earth, in some respects, is very special in that we live around a star that's one type, we have a moon. We're protected by Jupiter from meteorite. There's all these different conditions that seem to be make us unique. But I think that but I also think that life is so robust that it will happen at many other places. Basically, I'm trying to state both answers at the same time.
Okay. Interesting. So next question. When Western astronomers talked about intelligent life, they only refer to humans. Is that what you were explaining?
I think we use humans as the baseline for intelligent life. We don't really think, I think in our own system, we don't really worry too much about dogs as intelligent life or cats as intelligent life or other primates as really intelligent life. I mean, if you're a biologist, the view would be different. But I think from astronomy, we really start from the bias that humans are the intelligent life.
Okay. Can we take pictures of these planets really far away? So do you have a photo of them, or how do you see them? That's a good question.
So we tend to see them through the transit method. So we really only see them from how they remove light. There is a technique called high contrast imaging. Because we want to take a snapshot of the star, you have a telescope and the light's coming through. What you'll do is you'll put a little disc in front of the star to block it out. And if your telescope's really good, you sometimes see the planet. And so we've imaged, or I shouldn't say we've seen the planets, because we can't really image them like the artwork we have, but we've seen the planets existing around other stars in a few cases. But it's an incredibly difficult method to do because you're trying to block out 99.99% of the light. And for some of these cases, you're really trying to see like a nickel on the moon.
Okay, so you can. It's just hard to do, I guess.
For a few cases, you can.
Oh, okay. Didn't know that. Melissa says, thank you so much, Dr. Nielsen. Do you have any advice on how to integrate our own Indigenous knowledges with Western education in our own lives? So I guess that might apply to that one slide where you were showing the kind of, that's a good question, actually.
Yeah, let me see if I can. This the one? This is the slide you're referring to, Jenna?
Yeah, I assume so, just by the nature of the question.
Yeah.
Maybe you can clarify for us, Melissa. But
I think, yeah, please. That's a very big question.
I think you can start with this one while we wait for her to maybe.
Yeah, sure. So, yeah, this is a hard question to answer because, I spent so much time in astronomy that you start seeing these issues. I think in our day-to-day lives,
Oh.
I walk, yeah.
Yeah, okay.
I just think of living in Toronto, and I walk around the city, and you see a few trees kind of living on their own. You see a few raccoons and trash pandas. And I think how we view them tends to be, in an urban setting, tends to be very westernized. And so I think, I think the ideas of, from Indigenous perspectives here, I think it's about, reminds us to appreciate these animals. Raccoons might not be pests, as it were, or remind us to remember that our actions impact them. I think, from environmentalism, I think if Western society kind of looked at Indigenous knowledge a little more respectfully and thoughtfully, we would be a lot further ahead in terms of fighting climate change. But it's very hard for me to answer this question for anyone too, how to use it in their day-to-day lives. Because I think, or their own specific, more nation-specific knowledge is, because, you know, it's very much a relationship, and we all have to figure out how we relate to it. For me, I'm coming at this from a very Western perspective. You know, I grew up in Newfoundland at a time where being Mi'kmaq wasn't really talked about and wasn't really appreciated. So I never really got to explore these knowledges as a child or a youth. And going in the last decade where I've come to just start learning and appreciating. And so for me, learning and trying to integrate these knowledges is really about trying to find where I come from. And I think if you come from a place where this exists, it's about honoring where you have your knowledges and you know things like the language and the perspective, and it's about honoring it. And you know, and I keep thinking, I'm just listening to an interview with the poet laureate. You know, she had this. I apologize because I can't remember her name, but she had a line in her poem, and as a Cree poet, that we are the Big Bang because we come from the stars. And this has so many different meanings, whether it's literally coming from the stars as beings, or from the astronomer's perspective, where we're all made of star stuff, which Carl Sagan said decades ago, because the materials, you know, the Big Bang created hydrogen. Hydrogen is part of water, and that's what we're made of mostly. And we're made of star stuff because stars made everything else. And so the fact that we have an Earth and a planet meant that there were stars doing work for billions of years to create the materials that allow us to exist. And so those knowledges can work together. And so you know, when I hear we come from the stars, I hear that relationality. I hear that connection, and in the same way, if we come from stars, so do the trees, so do salmon, so do cod, so do bears, so do everything. And so that's part of that relation. And so I think I'm doing a very poor job of answering your question, but you know, I think it's something we have to work on ourselves as well. And I really hope that, you know, Western universities, and particularly in STEM, start doing this work as well, because, you know, from what I can tell, physics, astronomy, we need to be more Indigenous. We need to have these knowledges, or these knowledges don't need us, but we definitely need them, I think, to understand the universe in different ways. And so there's so much to offer there, and so much to learn from different nations. I'm sorry that was me rambling. All I can really offer.
It sounds like it's more of a way of thinking almost, rather than just following a set of rules, or I don't know how to explain it, but I think I understand what you're saying, and it makes sense to have. I like that the knowledge is holistic point. That kind of makes sense when you talk about combining knowledges from different departments and sharing how those integrate together. That's a very Indigenous way of thinking about things. So I hope that answers your question. If it doesn't, please clarify, Melissa.
Yeah, and I think to pick up on what you said is it's a way of being as much as a way of thinking, and that's part of the relationality of knowledge, right?
Yeah.
Because we're related, it's an action, so it's part of who we are.
Yeah, I definitely agree. Another question here. Is it possible to separate Indigenous religious beliefs from Indigenous ways of knowing? Interesting.
I tend to avoid the word religious with Indigenous knowledge, because I don't think it is possible to separate. But I also don't think we really do that in the West either. One of the great Western scientists who figured out the orbits of planets around the sun is Johannes Kepler, and the telescope was named after him. And you know, he came up with these laws and mathematics for describing how planets orbit our sun, and contribute to things like the beginning of physics with Isaac Newton. But when he wrote his treatise on this. He was so close to stumbling on the ideas of gravity that Isaac Newton did, but he referred to it as spirits. You know, a lot of times we try to think that Western science doesn't have religious beliefs in there, but we all come from our own biases in our own place. So if I come, you know, if I'm at a school with people who are Christian or religious in other ways, they're going to bring their perspectives as part of this. And so it's not about separating one from the other. I think it's about appreciating those biases, and I mean, I use biases in a very neutral sense here. It's about understanding how we learn and live and where we're coming from. And so I would not want to separate Indigenous beliefs or religious beliefs, if you want to use the phrase, from ways of knowing, because that's part of it. And it's an important part of it. It's part of that holistic nature. And I think without it, if we did try to remove them, I think we would remove something that a value for science. And so I wouldn't want to remove it.
So you're suggesting that they're kind of one and the same, I guess.
Yeah, it's a spectrum, right? I mean, I know elders in that who are very much about saying the words prayer and these things, but and thinking about, let's say, a smudge as a very religious ceremony. But you know, it also has health benefits. It has community benefits. It's not just, you know, I shouldn't say it's not just, it is many things. And it's also science. And we can learn from each, you know, science can learn from religion, or religion can learn from science in the West, and we shouldn't try to separate it in Indigenous knowledge, because that's part of what makes Indigenous knowledge unique.
Interesting. That's an interesting perspective. Great question. That looks like all for me. I think you answered all of them. I guess your answer was clear enough for Melissa. She didn't comment again, but I think it makes sense. Anyways, we're right on time, so we will end it there. Thank you so much, Dr. Nielsen. That was really great. And thanks everyone who attended these 3 days. If you missed any of the days, these videos will be uploaded to our social media and our website. And yeah, and thanks everyone for attending, and please look forward to future events from STOODIS, and possibly we'll hear from Dr. Nielsen again. So thanks everyone.